Hello, this video is about section 5.4, which is about SSS Triangle Congruence. So at this point, we've already learned about ASA, angle, side, angle, and we have learned about SAS, side, angle, side. So it's only fitting that we also learn about SSS. So the SSS Triangle Congruence theorem. Well, first, it stands for side, side, side. And what the theorem says is that if three sides of one triangle are congruent to three sides of another triangle, then the triangles must be congruent. So even if we know nothing about the angles, as long as all of the sides are congruent, so this one's congruent to this one's congruent to this one, and the third side is congruent to the third side. As long as all of the sides are congruent to each other, the two triangles are congruent to each other. That's what the SSS Triangle Congruence theorem says. So let's look at example number 1. Determine whether the two triangles are congruent. So we just need to look and make sure all three side lengths are congruent. So a 1.7 is congruent to a 1.7. 2.3 is congruent to a 2.3. And 2.4 is congruent to 2.4. So I have three sides of one triangle being congruent to three sides of another triangle. So yes, the triangles are congruent because of the SSS theorem, or the side, side, side. Example 2. Find the value of x that will result in two congruent triangles. So now we want to apply this SSS theorem to find an unknown value. So 4x minus 6 has to be congruent to 3x minus 4 in order for these two triangles to be congruent. So we're going to make an equation. 4x minus 6 equals 3x minus 4. If I want them to congruent, I want them to equal each other. So now let's solve for x. Subtract 3x from both sides. Four x minus 3x just gives me 1x, or x. Add 6 to both sides to get the x completely by itself. So x equals 2. One last example, a proof. Again, when we write proofs, we always start with the given information. So given that BD is congruent to AB and AC is congruent to CD, we want to prove that the two triangles are congruent. So we always fill in our given information in the top rows. So BD is congruent to AB. That was given. AC is congruent to CD, which is also given. And what we are trying to prove always goes on the bottom row. So triangle ABC is congruent to triangle DBC. So let's look at our diagram a little closer. We have two triangles. We already know that AB is congruent to BD, and we know that AC is congruent to CD. If we knew that BC was congruent to BC, then we could use SSS to prove that the two triangles are congruent. Well, of course BC is congruent to itself. It's one line that's a part of two different triangles. So again, that is called our reflexive property. So BC is congruent to BC. And now we can say that the two triangles are congruent to each other because of the side-side-side theorem.